Hi, in this video we're looking at the final section of the differentiation topic, and that is differentiation of parametric equations. Now, I need to explain what parametric equations are, and I've done that in this first paragraph. Basically, we have situations where variables like x and y are not directly related to one another, but they're related rather to a third variable. This third variable, to which the other two variables are related, is called a parameter. And the two equations then form what are referred to as a set or a pair of parametric equations. And they will describe the curve that is trying to be explained. So an example of this might be something like this. As a plane ascends after takeoff, its altitude increases at a rate of 45 meters per second, while the distance on the ground from the airport increases at 210 meters per second. So I've got two variables here. I've got the altitude and the ground distance from the airport. And each of those variables are linked to time, as seen by this 45 meters per second or 210 meters per second. And so I could write an equation for each of those. I could say that the altitude, which I'm going to call A, is going to equal 45t. And the distance from the airport, D, is going to be 210t. Now, each of those equations can be rewritten. I could say over here that t is going to equal A over 45. And here I could say that t is going to equal 210 over distance, d. They are a pair of parametric equations. The parameter that we're dealing with is time. Now, if we want to find the derivative of a curve that's described by parametric equations, we're going to use an adaptation of the chain rule. So, if we take a look at this example here, we've got a pair of parametric equations. X is equal to 3t squared and y is equal to 4 minus 2t cubed. Well, each of these I can derive. I can say dx, the derivative of x with regards to t, dt, that's going to be 6t. Whereas over here, I can say that dy, derivative of y with regards to t, well, that's going to be minus 6t squared. And if I want to look at what the derivative of dy dx is going to be, well, then I can say this is going to be dy dt times by dt dx. There's the adaptation of the chain rule that we're going to be talking about. Dy dt we have, it's over here, so that's going to be minus 6t squared. But dt dx I don't have. I have dx dt. So if I want to have dt dx, I need to invert this fraction over here. So I'm going to invert my 6t to 1 over 6t. And now I can multiply those two together. And what will I have? I'll have minus 6t squared over 6t, and that's going to simplify to minus t. And so we have the derivative of this curve as being minus t, not dx, dx. And so there we've got the derivative of this parametric equation. Now, sometimes we're going to need to change these parametric equations to Cartesian equations. So in other words, equations that are just involving x and y. So if your x and y values are defined in terms of the same parameter, all you need to do then is just rearrange the equations so that the parameter is the subject of the equation and then equate them. One thing to notice here, though, if your parametric equation involves sine and cos, and quite often they do, It's important to remember the identity that sine squared t plus cos squared t equals 1, because that's one way in which you can go about eliminating them within an expression or set of equations. So let's take a look at some examples here. We have a graph that's defined by the equations x is equal to 2t plus 1 and y is equal to 3t minus 2. So x is equal to 2t plus 1, y is equal to 3t minus 2. And all I have to do is to make t the subject of each equation. So I can say x minus 1 is going to be 2t, and so t is going to be x minus 1 all over 2. Here I can say that 3t is going to be equal y plus 2, and so again t I can say is going to be y plus 2 over 3. And we have here two variables, t and t, they're the same variables, and so I'm able to equate these two statements together. I can say x minus 1 over 2 is equal to y plus 2 over 3, and all I have to do now is to go and rearrange that equation so that we have y the subject of the equation. So multiply through by 6, and I'm going to get 3x minus 1 is equal to 2y plus 2. What have we got here? Not 3. 2y plus 4 is equal to 3x minus 3. So 2y is going to be 3x minus 7. And so I could end up saying y is going to be 3x minus 7 all over 2. There is the parametric equation rewritten in Cartesian form. Here is another example. Here's an example that's got cos and sine involved in it. So I've got x squared, x is equal to 5 cos t and y is equal to 4 sine t. So we're going to use that trig identity that sine squared plus cos squared equals 1. Now at this stage we don't have sine squared or cos squared, so what I'm going to have to do is I'm going to need to square everything. If I just rearrange these slightly, I can say x over 5 is equal to, I keep wanting to put cot t, cos t, and y over 4 is equal to sine t. And now I go and square both sides, so that goes and gives me cos squared t is equal to x squared over 5 squared, and sine squared t is going to give me y squared over 4 squared. And now I can combine these two together, so I can say that cos squared t plus sine squared t, well, that's going to equal x squared over 25 plus y squared over 16. And as you well know, cos squared plus sine squared equals 1. And so I've got the circle x squared over 25 plus y squared over 16 equals 1. The radius is 1. So there we have a circle centered on the origin. Taking that further, we can obviously be expected to answer questions about normals and tangents, things like that, to curves. And so here we've got that y is equal to t squared, x is equal to t cubed, and they want to find the normal to the curve at the point minus 8, 4. So if I want to find a normal, I need to know the tangent. And if I want the tangent, I need to get the derivative. So I need to find out dy dx. at this stage I can find dy dt, that's going to give me 2t, and I can find dx dt, that's going to give me 3t squared. And so if I combine these two, dy dx, that's going to be dy dt times by dt dx. We have dy dt, that is 2t. We don't have dt dx, we have dx dt, so we need to take the reciprocal of this. So we're going to multiply this by 1 over 3t squared. And when we combine all those together, we're going to end up with 2 over 3t. That is what dy dx is. So that's the formula for my tangent. And I now need to try and figure out what the situation is in terms of what the tangent actually is. Now, in order to work out what the tangent is, I need to know a value for t. And at this stage, I'm not sure where I can go to. Well, what I can do is I can go back to my initial statement over here and this point that they've given me over here. I know that x is equal to t cubed. I also know that x is going to equal minus 8. So in other words, minus 8 is equal to t cubed, and therefore I can say that t has to equal minus 2. In which case, dy dx is going to be 2 over 3 times minus 2, and that's going to give me value of minus 1/3. So there is the gradient of my tangent. I'm wanting the gradient of the normal, so the gradient of the normal is going to be the negative inverse of this, and that's going to mean the gradient of my normal is 3. In which case I can then take, dealing with the point minus 8, 4, so I can say the equation of my normal is going to be y minus 4 equals 3x minus 8, in other words x plus 8. So I'll have y is equal to 3x plus 12. And there is the equation of the, no, it's not 12, 3/8 are 24. That's wrong. 3/8 are 24 plus another 4 gives me 28. So there's the equation of my normal. Hope that all makes sense to you. What you need to do now is to go and practice. Goodbye.